Hello class, and welcome to Lesson 15. Lesson 15 that we're going to be looking at today is actually just a review lesson. And what we're going to be reviewing are all of the ways we have learned to display equivalent ratios. So now I'll take the time to zoom in on the first half of the page for your notes. We'll look at everything above the table. Now would be a good time to pause. And here we see everything from the table down, the bottom half of the page. Might want to pause and get this in your notes. As I said a moment ago, this is a review lesson. So what we're going to trying to answer is what are some ways I can display equivalent ratios. We know, we've studied over the last few weeks these four techniques. Tape diagrams are what we started out with. Then we moved into using ratio tables. Then we started using double number lines and a coordinate plane or a graph. Another way to think of that, another way to think of coordinate plane is a graph. So, our example ratio that we'll be using is going to be display equivalent ratios to the ratio 3 to 5. So we're starting each one of these ratios with 3 to 5. And we'll drop down here in a little bit to see the rest. But our first technique, we'll be using tape diagrams. If you recall, 3 is on top, 5 is on the bottom. You have 3 boxes along the top, 5 boxes along the bottom. Most important thing to remember is that once you know the value of one box, you know the value of every box after that. All of the boxes have to have the same value in them. That's the only way it works. So here, if we're starting with 3/5, we are representing with these 5s in each box the equivalent ratio of 15 to 20. Here, our multiplicative constant is what gets put inside the box. Now this is a really awesome model in order to visualize one specific equivalent ratio. The one specific equivalent ratio we're showing here is 15 to 25. However, tape diagrams aren't great models if we want to show a list of equivalent ratios. Best way to show a list of equivalent ratios is, let me get rid of that circle there. Best way to display a list of equivalent ratios is by using a table. So in a table, we're starting with our first ratio of 3 to 5, and from that point on, we are just filling in the rest of the x column. So starting at 3, we count by 3 every time. 3, 6, 9, 12, 15, so on and so on. And our bottom value, or our y row, starts with 5, and we count by 5 each time. 5, 10, 15, 20, 25, and so on and so on. Now, the table is a cool model because it's a great way to organize all of the different possible ratios forever and ever and ever and ever for any given ratio. So if I wanted to, I could come over here and I could extend this table forever and ever and ever and ever. And all I would have to do is keep counting by 3 on top. So 24, 27, 30, 33, 36, and so on and so on. Down here, same thing. Keep counting by 5. 45, 50, 55, 60. And it goes on and on and on until we run out of ink. Forever and ever. You hopefully remember how to do ratio tables. So, the next one we have, whoopsie daisy. The next ratio, we're going to use, next model we're going to use to display our ratio is going to be the double number line. Try not to pay too much attention to the graph next to us. We'll get to that in a moment. But the double number line is very similar to a ratio table, except instead of it being in a table, it's on a number line. So if you recall, we draw two parallel number lines. Start with our first ratio, 3 to 5. We add 3 on top, add 5 on the bottom, so it goes 3, 6, 9, 12, 15, 20, 15, 18, so on. Count by threes all the way over. Down here we start with 5, count by 5, 5, 10, 15, 20, 25. This is nice. This is a nice model too, because similar to the table, this can go on and on and on as far as you want. So this can keep going till forever, right? Another neat reason why we would use the double number line is if we want to find some figures in between. Like let's say I wanted to find what the value of 7 was. 7 would probably be right here. So I'd bring this all the way down, and I would try and figure out what would go at the bottom of that. What would be the y value that goes with the 7? And hopefully you remember how to do that. I won't go into detail. You can go back to that lesson if you forgot. But you want to find 2/3 of 5, and that'll add that to 10, and it'll give you your answer. But this isn't necessarily a review of how to do that quite yet. And last but not least, we have our coordinate plane, also known as the graph. Whoops. There we go. Come on. All right. No. Hopefully you're not too dizzy after that. But we're looking at our graph. Our starting ratio, as always, is the 3 to 5. Now the neat thing that you have to remember about the graph is that your first value is the x. So your 3 value goes on the x-axis, and your y, your second number 5, goes on your y-axis. This is pretty simple, right? So if we're starting at our x-axis and we're going 3 over, start at 0, count 3 over. 1, 2, 3, there's our 3. Okay, and then count 5 up. 1, 2, 3, 4, 5. It's that simple. Now from this point, again, we take our ratio of 3 to 5. We move on the x-axis, which is left and right, 3 spaces. 1, 2, 3, and then 5 spaces up. 1, 2, 3, 4, 5. And if you look closely, the coordinates for that second value are an equivalent ratio, 6 to 10. Okay, our next value, the coordinates are at 9 and 15. So our next equivalent ratio is 9 to 15. Does that look familiar somewhere else? Are we seeing 3 to 5, 6 to 9, and 9 to 15? We are indeed. The graph is a neat way to model because if you had a huge graph, will go on forever and ever and ever, and you can see how extreme the ratio is based on how steep it is or how not steep it is. If this graph went on and on forever, you'd be able to follow it up all the way on. Anyway, so that is how we use a graph. I will try and get rid of all of these, all these extra things we got here. Get you back to the home page. Okay. This is our notes, and whenever you have a review, typically there is some sort of a test coming up, and that we do have. We have reached lesson 15, which means we're at the middle of our module, which means we'll be having a test on these 4 models of ratios.